Hi everyone, I'm Dr. Mesra Isa Muhyiddin from Petroleum Engineering Department, University Technology Petronas. I'm glad to share our invention, sand erosion and corrosion software. The co-inventor of this software is Associate Professor Dr. Mukhtar Ismail from Mechanical Engineering Department, University Technology Petronas. The software has been developed to solve a real problem that we are facing in petroleum industry. When we are producing sand from unconsolidated reservoirs, and if there is some amount of CO2 present in the produced oil or gas, the action of these sand particles with the CO2 may lead to erosion corrosion. If we have pure sand, then we'll be having pure erosion. If it is pure CO2, then it's called CO2 corrosion. But if we have a mixture of sand or coexistence of sand plus CO2, this may cause very high degradation, and it's called erosion corrosion. So this erosion corrosion will cause very severe degradation to piping component downstream to the reservoir, which may lead to negative impact on economy, environment, and safety. Therefore, it is very necessary to early predict the exact amount of erosion and corrosion. There is some predictive tool for erosion corrosion available in the industry, but what is different in this software, it is more comprehensive, more accurate, flexible, and accessible for prediction of pure erosion, pure corrosion, and erosion corrosion. And it also includes more generalization of some models available in the literature. For example, it includes Northrop model for CO2 corrosion prediction. But we improve this model and extended its applicability to elbow geometry, long distance pipelines, and to prediction of erosion corrosion. The original model is only applicable for CO2 corrosion in very short piping system. The software also includes improved DIM model. The original model developed by University of Tulsa. The new model is more accurate when we apply it for viscous oils. The software is shown here. The main graphical user interface is shown in the upper left side, and then these are examples of the input data form. Depending on the model that we use, the graphical user interface will navigate to the correct input data form. Then finally, we get the output in 2D or 3D. Here are examples of 2D figures and 3D figures obtained for erosion and corrosion, and it shows the effect of some parameters on the erosion or corrosion rate. And also, here are the form of table output, which can be exported to Excel file. The accuracy of the software has been confirmed by comparison with 3 sets of data. The first set of data is data we measure at lab using in-house fabricated flow loop, as shown in the upper left side. This flow loop can measure erosion or corrosion in elbow and straight pipe. And the second set of data is published data for erosion and corrosion, and the third set of data is CFD result. So all the comparison of our software result with all this set of data confirm very high agreement of the result with the measured data. The current status of the invention is that it is filed for copyright with the number 15096, and it is currently in use as erosion and corrosion prediction and analysis tool inside UTP. We mainly use it for academic and research purpose, but in future we are planning to commercialize the software to oil and gas industry, to chemical processing, to slurry transport, and to other similar industries that may face erosive and corrosive problems. So far, we published around 9 articles from the result of this software, including 4 journal papers and 5 conference papers. We have also been awarded the Best Paper Award in the 13th International Conference on Pipeline Safety in China in 2020. That is all. Thank you.